Okay, so here it is now, fully built and populated. I've raised the height of the, or the clearance between the Raspberry Pi and the base. So I can now, I can get my finger underneath it to pull that out. I do need to get some, even these screws aren't quite long enough, but these are the longest ones I had, so I've used them, but I'm going to get some longer ones. I've got the two disk controllers plugged into the two USB 3 ports, power for the Raspberry Pi and power for the disks coming through these. You can see the two disks mounted here, and you can see them here. It's not particularly clear, but unfortunately that's the best I've got. So there's the two disk controllers, power coming in here, and I've got this splitter here so that both disks get powered at the same time. And that's it, all ready to go. I'm going to now get out the that's the other thing I couldn't remove. I couldn't remove this before as well. So there's the memory card. So I'm going to load up, I'll leave that out actually. I'm going to load up Raspbian or Ubuntu. I need to decide which to put on it. 64, I'll go for the 64-bit one. Get that loaded up and get this booted. So there we go. That's it. Okay, now that we've got the hardware built, we need to configure this server. And what I'm going to do is just build kind of like a standalone RAID 1 server that's ready to install any piece of software on. And then I'm going to install the NextCloud on that, but we can use that standard configuration process to build another server to run anything, Plex, NAS, whatever you want. So first things first, I've downloaded Raspberry Pi Imager, and we need to configure some SD cards. Now, because I'm going to be installing NextCloud, that doesn't work too well with Raspberry Pi, Raspbian. So I'm going to be installing Ubuntu because that has better support. So I'm going to choose server 64-bit LTS. There we go. So it's got long-term support. That's what that means. And we'll install it there. And let's set some configuration first. Set hostname CloudServe. Enable SSH. Set default user. We don't need wireless LAN. Europe, London. Okay. Save, and let's write that. Now, as soon as this starts writing, it's going to clear the partitions on there. I'm expecting a load of error messages. There we go. Right, so what I'm going to do here, the instructions for this, you need to have access to 2 Linux images because you can't make detailed system changes on an active configuration. It's, well, I don't know, it may be too difficult, maybe impossible. So what I'm actually going to do here is configure 2 SD cards so I can actually boot a single Raspberry Pi as 2 different computers, because what you'd, in an ideal world, and what most of the instructions have, is people run Linux as their desktop and they're building another machine, so you configure it on the server, and then when you need to make the hard changes to the boot, you can just put them on your workstation, make the changes, and then put it back on the Raspberry Pi, and away it goes. But I've only got a Raspberry Pi, and I run Windows on my main PC. So I'm going to configure two SD cards. One that's actually going to be the server, and the other one is just going to be a separate SD card that I can boot up the Raspberry Pi, and it will think it's a different computer, and then I can access the other SD card and make the few. There's only a few minor configuration changes, but I can't edit an ext4 drive on Windows, so I need to have access to Linux. So that's what I'm going to be doing. So I'm just going to build two SD cards here, and I'll fast forward this bit until they're done. Okay, so that's the first one done. Move the SD card. Now I'm putting in the other SD card for the config. Oops, config server. So, right, so I'm going to install Ubuntu as well. What do we got here? Let's call this config. Need SSH. Config ADM. And all the rest can be the same. Save. And right. Okay, that's those two done. Move the SD card. Continue. Right, we're done with that. So the first thing to do is insert the cloud server SD card and get that configured. And get it in the slot. There we go. Right, let's power that on. Right, let's see if we can connect. No. Okay, login as. Okay. First of all, let's update this. Okay, so I can see here that warning message is upgraded to 1026. So, right, that's all done. Let's have a look at what we've got. We've got some devices. We've got SDA1, STB. We've got boot, and we've got the root file system here. Right. So this is not my first attempt at doing this, but you can see it's already, so it comes installed with MDADM for RAID support, and it's already found and created this disk MD0. So says it's clean. Okay, so if I carry on here, it's not going to be very useful to people. So the first thing I'm going to do is stop this array and erase it. If you haven't running an array, then obviously you won't have to stop it. You can just go straight into the creation steps. So anyway, stop. Let's stop this. Okay. Let's have a look here. We have got. Where are we? Here. So there's no longer an MD, and there's no longer an MD0. Okay. So that should remove the super blocks. Okay, so that means now that there's no, doesn't recognize these as part of a RAID array. If we try symbol scan, no arrays find in the config file or automatically. Okay, so if you haven't already had an array installed, or then this is where you start. If you have, or you're trying to repurpose a disk which may have one on, follow those previous commands and you will be able to clear out the old array. So I'm going to start as if it's a brand new disk that hasn't been used at all. So first thing, let's initialize these disks. So these are over 2 terabytes. These two disks, they're 2 4-terabyte disks. So I can't use an MS-DOS type disk structure. So I've got to use a GPT. /dev/a. Yes. So that's formatted SDA. DB. Yes. Now, what devices have we got? So we now have SDA and STB. So there's no disks, mountable disks on any of those. So now we need to create disks on those, format them. So let's go gdisk /dev/SDA. sudo. Right. So let's delete any existing partitions. It says there's none found. So we'll create a new partition and we'll take the default of 1. We want it to go from the first sector, so first point on the disk it can, so it's recommending that for us, and it also around the end of the disk, so all the way to the end. Now the code we want is an FD00 for a RAID array, and W to write it. Yes, we want to proceed. Okay, so that's done. Now do exactly the same for SDB. So let's delete no partitions. So default 1, yes. Default beginning, yes. Default the end, yes. And FD00 and write. Yes, I want to proceed. Okay, so we've now initialized those 2 disks and created 2 partitions on them. Let's just recheck these disks. So we did the examine on SDA1, so let's recheck these, and now we see no superblock exists. And SDA, and they're just defined there. Okay, so that's all ready to go. Now we just need to create the array. mdadm create md0 mirror devices equals 2 mirror, not mirror, equals 2, and they are /dev/sda and /dev/sdb. Oops. SDA1 and SDB1. Yes. Okay. And that's now created a brand new array for us here. So let's examine these now. And now we get that there's a RAID array on these 2 disks. It says it's active. Available size. Okay. Right, so let's have a look at MD0. And here is the array. That's array size 3.6 terabytes, 2 devices, and it's clean and it's resyncing at the moment because it's got to go through and sync the whole thing together. Let's try this. Okay, so that tells us about how well it's synced. Active RAID 1, STB1, SDA1. And it's going to take 488 minutes, so that's about 8 hours. But I think that we can, while that's resyncing, I think we can just carry on with this config. Let's see. Okay, let's create a file system now on this disk. There we go. Right, let's have a look at it. So we've made a mount. Oops, we've made a mount point called RAID 1, and now we're going to mount that disk on RAID 1. Let's have a look at it. Well, and that's what I expect to see on an empty disk. File system dev md0. Good. Okay, so we've got a bit more config to do now. So that's still in progress. Right, so we need to back up the configuration. Sudo mdadm tail scan. So basically, what we're doing here is we're using mdadm to give us a display of how the array is configured, and then we're storing it we're piping it into this mdadm.conf file, and that's how you can build the config for it, rather than have it try and scan it and possibly get it wrong. So we just load it into there manually, and that's what it's actually going to store in that file for the config. Okay, so that's created the config for the array. Now we need to update the disk config. So we're just updating the boot image so we can see the disk. Okay, so that's all of this done now. What we need to do now is boot into the other SD card. So what I'm going to do, I'm going to take this SD card out of the Raspberry Pi and put it into an SD card reader that I'm going to plug into the USB slot of the Raspberry Pi, and then I'm going to plug the other SD card that we initialized into the Raspberry Pi and boot that up. So then I can copy the root file system from the server SD card onto the actual USB disk. I think I might put in a picture for this because it's a little bit complicated, or a diagram. Yeah. Okay. So anyway, I'm going to crack on with that. So let's shut down. So we start with a Raspberry Pi, and we add two hard drives attached to the two USB 3 ports. They will be configured in a RAID 1 or mirrored configuration. Then I used the Raspberry config tool on Windows to configure two identical SD cards with Ubuntu server on them. One will be used for the actual cloud server, and the other will be used to enable me to finalize the config. Both SD cards have two partitions on them. One is the boot partition, and the other is the root partition. First, I boot the server from the cloud SD card, update the software, and do all the base config to define the RAID array. Now, I want to copy the root partition from the SD card to the RAID array. But I can't do that because a load of the files are in use by the running Linux image. So, I shut down the server, take out the SD card, and replace it with the config SD card and reboot the server. Just as before, I update the image so they're both the same, but this time I just add the RAID array to the config as the disks are already configured. Now, I put the cloud SD card into the SD card reader, which I've plugged into one of the other USB slots. I can copy the files on the root partition of the cloud SD card onto the partition on the RAID array, because the files are no longer in use. I then modify the config on the cloud SD card boot partition to tell it to find the root partition on the RAID array rather than the SD card. Next, I shut down the server again, remove the config SD card, replace it with the cloud SD card, and reboot the server. The server uses the boot partition from the SD card, but the updated config tells it to find its root partition on the RAID array. The boot partition hardly changes, so it can remain on the SD card. The root partition changes all the time, so I get the reliability of a hard drive for this partition. So I've just checked on the firewall, and for some reason that's booted up as a .67 instead of .66. So I'm just going to open a new session. So log in as. So this time it was the config server. So config admin. Okay. So we're logged in. If we do an ls now, so it's found that disk, but it's loaded it as MD127. Do we have an MD? Okay, we've got an MD127 there. It's found it and loaded it. Anyway, so let's do the upgrade first before we do anything. Sudo update. Just so that both operating systems are running on the same versions, we don't get any compatibility issues. Okay. Okay. Okay, so we've logged in. I can see again we're running 1026 Raspberry, and we're in. There's the disks. Interesting. It's now picked up as MD0. And we've got MD and MD0 and SDB, SDA, SDA1, SDB, SDB1. So it's automatically loaded that as MD0. Cool. Let's do a little display. That says clean resyncing. It's 2% complete. And let's do sudo mdstat 2.9%. It's going even longer to finish. So that's just running through doing its thing. Okay, so we now need to get the what's the word? Copy the boot sector from that's on the server SD card. Oops, don't want to do that. The boot sector on the server SD card onto the. Let's get rid of that one. This one a bit bigger. And let's have a look. So I've just plugged in the SD card reader. Cool, what have we got now? Where did SDE and SDF come from? And SDC. So, oh right, these are the other potential types. Okay. So I was getting puzzled there. Okay, so I've plugged in the SD card reader, and it's got 4 slots for 4 different cards. So that's going to be SDC. SDD is the one that I've actually got the SD card in, and then I've got SDE and SDF. They're the 4 slots. So it's just showing me all these empty slots. So let's get these mounted, and I can get access to them. So let's make a directory there. bootfs /dev/std1. So the first partition, which is the boot partition, if you look here, this is the first partition, and it's the boot partition. So I'm going to mount that as bootfs, and then this one I've called rootfs, and the second partition is the root file system. So let's have a look at that. Right, and that's all of the files. If we look at the root on this PC, this instance, then we can see that it's exactly the same files there. And slash, and that's the boot directory. That's got config and all the other things in it. Okay, so now we need to start editing some of these files. Well, we need to copy all of this stuff over onto the onto the RAID array, and then start editing some of these boot files. Okay, so let's start doing this configuration. So first thing, sudo nano /mount / file system, and then we want the etc. fs-tools/modules. Okay, and we need to RAID 1 md_mod and ext4 o.x. Okay, so that's that done. And we need to make use of that and build the file system for boot. Sudo mk fs mount / rootfs bootfs / z. RMFS mk init RMFS move RAID gz. Okay, so let's make a backup of that. So that's the standard they seem to be following. Okay. Set to MD0 and let's add root delay equals 5. So that says try and boot from there and wait for 5 seconds in case it doesn't come up. So that's exit. Now let's copy. Where are we? Now we need to update the root, the FS tab. First of all, let's copy all those files across. Copy all those files, /md /red1. I don't know if that's meant anymore. Okay. No, red1. Oh, I never added it to this one because I never mounted it. Red1. Okay. No. Okay. Sudo sync -a. What was it? x3 /p. So that will copy the whole of the root file system from the server's SD card to /md/1. Okay, so that's done. So we have copied all the data across. Okay, so that looks like a root directory. We've edited the config to say boot off it. We need to update FS tab. No. I'm not going to edit this FS tab. /mount/raid1. Right, so I'm going to comment that one out. And we're going to have /dev/0 be root ext4. No wait time. Okay, that errors equals dash remote read only 0 1. Okay, so that's pretty much it. Okay, so low, so X. Okay, so that's the FS tab there. The was actually on the RAID array. I haven't edited the one that's on the SD card. Okay, let's shut down and reboot. Shut down. Put the other SD card in and reboot it. I don't know. Okay. Right. So I think that's rebooted. Move. Oh ho. Well, hey. And there's my boot. My root file system on the RAID drive. Boot sector is still on the SD card, which is fine, and the old root file system's not used. Fantastic. What have we got here? MD0, SDA and 2. Okay. Let's just check out this. Okay, that's still resyncing. Excellent. %. Fantastic. It's automatically picked it up, carried on syncing it. In fact, by how much it's done, it looks like it was resyncing it on the other one as well. Superb. Superb, superb, superb. Okay, so we've got the server built. So we've now got a vanilla Ubuntu server ready to run, running on a Raspberry Pi, ready to install any piece of software we want. And we've got resilience, RAID 1 resilience, so mirroring on the main data disk. So we've got resilience there. We've got the boot directory, the root file system is on the disk as well, so we don't need to worry about burning out the SD card. So we are good to go. Right. I may leave this to sync itself, or I may start loading up. Anyway, I'm going to make a break here. And the next video, I'm going to install NextCloud and configure. So this is the base server build done. See you in the next one.